This is our first webinar that we're doing with Gravitino and Data Strato, so I'm really excited. Hopefully this will be the first of many, but we're always welcoming feedback or anything that you might have as well. We're really wanting to make sure that this sort of community event provides value for the people who are attending, so we are always looking for feedback to make it better. A little bit about today, we're going to be talking about some different strategies for optimizing Iceberg tables, including ways that you can do it with Apache Gravitino specifically, which has a IRC implementation. And a lot of this is really focused around large-scale Iceberg deployments that you might be really thinking about the cost effectiveness of how to make sure that you're running jobs as efficiently as possible. And today there's going to be two folks who are going to be with us and presenting today. Unfortunately, Justin could not make it today, but he is going to be making an appearance in the form of a video. So he's going to be here in some sort of way. And then myself and Jerry are here as well. So a little bit about what we're going to be doing today in terms of game planning and what our agenda is going to be. We're going to really very lightly touch on what Apache Iceberg is, just so that we're all kind of on the same page. But generally speaking, this webinar is not meant to be, a what is Apache Iceberg webinar. We're going to be expecting that some folks have an idea of what Iceberg is, and you might already be using Iceberg already, and maybe you're interested in kind of really edging out some of the performance of your Iceberg tables instead. We're then going to be talking about some of the different facets for maintaining Iceberg tables and what that might look like and where you might be concentrating your efforts on as well, depending on what your use case is. And then we'll also be going into Apache Gravitino. We have the creator here, Jerry Shao, with us, so it's going to be really exciting. Also means that any deep tech questions you might want to ask about Apache Gravitino, he's going to be here to answer them as well. And he's going to be doing a deep dive with us into Gravitino's Iceberg REST catalog implementation and some of the ways that Gravitino can be used uniquely to optimize Iceberg table maintenance and kind of your storage strategy when it comes to your Iceberg tables. And then we're going to be having a demo of what it looks like to actually interact with Iceberg using Gravitino as well. And we'll be opening up some time at the end for some Q&A. So a little bit about me. I am the product manager at Data Strato. Pretty much that's it, I would say. I don't really do too much else, but Jerry here is also joining us, and he is the CTO at Data Strato. He's also, like I mentioned, the creator of Apache Gravitino. We also have some of the folks here who helped implement the IRC specifically in Apache Gravitino. Xiaojing is one of them, so thank you so much. He's in the chat, so if you have any questions, feel free to type them in. Jerry also, has been working a lot in big data for quite a while, including, Apache Spark and other big data technologies. So a very decorated resume, I would say for sure. Jerry, I don't know if you want to add any more to that, or if I can just continue. I think that's good. All right. And missing today is our community manager at Data Strata, who is Justin McLean. Justin is VP of Incubator at the Apache Software Foundation. But generally speaking, if you're going to create any like issues or if you're going to try and pick up some feature work in the Gravitino repo, chances are that you will see his name pop up once or twice and you'll be interacting with him. So just a little introduction there for you. So a little bit about Apache Iceberg and just kind of introducing and setting the scene just to make sure that we're not just straight up going into optimization. Uh, Generally speaking, why open table format has been really important, like Iceberg, has generally been, this sort of reclamation of storage and compute as sort of like this decoupled architecture. And the more control that you have over these individual components, the more that you're able to customize them for your specific needs in your organization. And so with, open table formats such as Iceberg or Hudi or even Delta Table, we're able to choose the processing and query engines that we interact with specifically more independently, but also have agnostic storage formats. So this includes basically, being able to store, S3 buckets or MinIO or on your GCP or, whatever cloud provider that you're working on as well. And then being able to have this common spec between all of them that then your query engines can consistently work with and understand. So this can really help with, reducing the need for duplicating data across different cloud providers or across different object stores. And it can really improve efficiency too if you really know what you're doing. But one of the really important things as well here is that we can actually leverage the catalog that's implemented specifically in Iceberg to actually streamline our data governance and our access controls. So if we wanted to look at Iceberg at like this really high level and like just sort of this really quick nutshell, again, we're not going to be going into this too deeply. There's tons of materials out there for learning a little bit more about what Apache Iceberg is and its architecture. But generally speaking, I think it's really important just to remind us that what makes Apache Iceberg so deeply valuable is the fact that it does leverage metadata really well in sort of like this hierarchical fashion. So at this very base layer, you have your data files, and of course, your delete files that are going to be generated as well as your creating or deleting records. And then you're going to have that, either stored in your file system or your object store. And this is pretty agnostic, but generally speaking, you're going to see, these data files in either Parquet format or Avro format. And on top of that is really kind of the bread and butter of what Iceberg is, which is the metadata layer. So above that, you're going to have your manifest files, and then those files are going to be contained in your manifest lists as sort of like these lists of your manifest files. And then that's where your snapshot information is going to be contained. And then above that, you're going to have your metadata, where you're actually going to be tracking your individual snapshots. So again, we won't really go into this too much, but generally speaking, a lot of this is sort of in this hierarchical fashion where you can then contain really rich metadata around your partition information, around information about the schema, your column statistics, stuff about where stuff is stored, and all of these sort of like statistics and metrics can actually be used analytically to actually leverage and optimize your different, say compaction or pruning techniques, for instance, and how you want to manage those. We also have above that the catalog, which is something that we're going to be discussing a little bit more in depth as well. And the catalog in sort of like basic Apache Iceberg is really just going to be your pointer to the current metadata file. So it's nothing really fancy, but a lot of IRC implementations have been created in order to add more richness in terms of features and governance on top of that. So hopefully that wasn't too much thrown at you. This should hopefully be review, generally speaking, if you're in a webinar like this, but we're going to be going into some other stuff too. So I want to start off with a poll for us. And generally speaking, I have not really done too many polls in Zoom before, so we're going to go on this journey right now. But I'm going to launch this poll and, hopefully please answer as honestly as you want, no judgment. But we're going to be asking you some different questions around where you are in your iceberg journey. And so if you can see the poll, you should be able to vote. And can I just get a thumbs up that everybody's getting this poll? Generally speaking, we want to know where people are at in terms of their iceberg journey. So are you, just kind of evaluating it right now? Are you currently using it in production? Or are you currently like full-fledged, full in on Iceberg currently, and you're really, implementing it with multiple teams so far? Or are you not even using it yet? You have no plans to use it. You're just here for fun. And commending you here for learning about Iceberg where you don't really have to. So currently, quite a few folks have, I think most folks at this point have participated. So it seems like a lot of folks here are actually still evaluating Iceberg. And so I imagine that maybe, the other half is probably in production as well. So there's a really good mix of different folks here who are either still evaluating or using it currently full-fledged. And so I would say that probably maybe some of the interest is around, how much work is going to go into optimizing it if we actually do end up using Iceberg. So I'm going to end this poll. Thank you all for answering. You can expect more polls as well. And these are going to be the results that we have here if anybody else wants to take a look at them. And I'm going to stop sharing those results. And perfect. So let's go into actual table maintenance and what that might look like. So a really big area of table maintenance is going to be your file compaction. So generally when you're working with Iceberg tables, you're going to be rewriting and actually creating a lot of small data files and that you're appending to, or a lot of delete files as a result. And so compaction is sort of this process of taking these small files and then compacting them, merging them together into these larger files periodically, so that when your query engine is, scanning or working with this data, it doesn't necessarily have to work with so many small files. including the metadata as well. So this reduces the overhead and reduces the amount of planning that maybe the engine has to do, and of course the input-output overhead as well. So of course, Iceberg has a very incremental strategy when it comes to doing these reads and writes, but also when it comes to inserting and tracking deletes. So this can actually be quite a big area when you're working with a lot of streaming data or if you're frequently updating your data, just because these small data files can accumulate and again become really inefficient for you. And so if you're tracking or like triggering these compaction jobs manually, or if you have some sort of automated system, this can really help to optimize your performance. And of course, depending on which kind of tools you're using, you might be using a specific query engine in order to run these jobs, but you're also probably leveraging the rewrite data files action as well that Iceberg has built in. And so you can do compaction on the partition level as well if you're working with really large tables, or you can schedule compaction in a way that either is both suitable for you based on sort of like data freshness instead of just like constantly running compaction jobs that might be more expensive and not necessarily worth your time either. Which gets us to two different strategies that you'll have when working with Iceberg. So typically when you're working with Iceberg tables, you either have a merge on read or a merge on or a copy on write strategy. And generally, this is meant for, different workloads that either need to optimize your reading or your writing, right? So if you're merging on read, you're looking to have faster write times, and that way you're going to have to merge your base and delete files as you're reading it. And then this is kind of very suitable if you're working with ingestion systems that, are ingesting a lot of data at a given time and require very low latency needs. But kind of the write-off here is that you need to have more efficient pruning management, as well as you have to manage a lot more delete files as well. Whereas when you're choosing a copy on write strategy, generally speaking, you're going to have slower writes, but you're going to read much faster. And so this is generally speaking kind of better for like large batch workloads, or if you're working with really like analytics heavy scenarios as well. And then you're going to sort of periodically rewrite or incorporate your deletes and updates. And so which strategy you choose really depends on you and what you're using this data for and what you kind of need. But generally speaking, you might want to also play around and see what works best for your team. So also another big part of this, as we kind of mentioned, is managing delete files. And so Iceberg does support positional deletes, so depending on the position of the row, but also quality deletes, so based on some sort of condition that you feed it. And generally speaking, if you're accumulating a lot of delete files at any given time, especially if you're choosing a merge on read strategy, you're going to have a high degradation of query performance. So you're going to have very slow queries just because there's going to be a lot of scanning that has to occur. And so some different strategies that you might implement here are actually rewriting the delete files using compaction, or you can, use copy on write as well. So generally speaking, I would say that the best sort of practice here is to use and leverage the metadata and the table metrics in order to understand, where you're getting a lot of inefficiencies from. So this can also include tracking your delete file growth. Another option is looking at your pruning. So again, if you're maintaining your own, Iceberg tables, you're going to kind of touch all this stuff in very different places. So pruning is kind of this way that you're going to remove maybe old data files that occur, or cleaning up different partitions or row groups. And this is kind of based on different query filters that you might enable as well. And so really this generally happens during the query planning, and you're going to use metadata to kind of help identify where might be some good places to prune by. So there's a few different options. So you can prune by partition, for instance. You can also use a hidden partitioning scheme, or you can use a manifest partition pruning, or you can use the column statistics as well. Generally speaking, this is really going to be up to you and what works best for your system. And partitioning as well, we've kind of mentioned this a little bit with pruning, but there's many different ways that you can partition your Iceberg tables and that data in order to kind of make the most sense as you're querying as well. I won't be going into this too much. There's a lot of different ways and a lot of advanced ways that you can partition, as well as prune, like using many different fields at once. So I've kind of showed some really simple stuff here. but this might be a good avenue for you to go down if you're really interested in this. So for instance, if you wanted to, you can do like multi-level partitioning as well, or you can do more dynamic partitioning methods. You can also use Z ordering as well for something that's, again, more cluster-based. And generally speaking, the way that you partition is just like any other, large data distributed system problem that you might have within your organization. So we're also going to talk a little bit about the metrics and the metadata tables that you might use to optimize here. So Iceberg is really cool in that it stores a lot of really rich data, kind of like I mentioned before, specifically the metadata fields that you'll have in metadata tables in like these sort of like different manifest files and these sort of different metadata files. And also in terms of log generation as well. And so you can use this to create different ways to optimize, and you can actually track where some of your inefficiencies are. So some examples of different fields that you can leverage here are sort of like record count, file sizes, the column sizes, your partitioning information, and you can sort of leverage these. And one of the cool things about this is that you can actually query the metadata using SQL, right? Which gives you a lot of really cool ways to work with that data. And you can track how those partitions maybe have changed over time, the size of the data and how that's changed, sort of where different data is lying, and sort of where poor clustering might be occurring, or where you're generating a lot of small files. So this can, of course, all be used to power, your pruning decisions, your compaction decisions, allows you to maybe detect some skew that might be occurring in your data as well. And if you want to also leverage maybe your snapshot history, you can track maybe some of the jobs that you're working with, and clean up those individual snapshots as well, or use these individual metrics to maybe, trigger some sort of optimization flow that you have built in. And so for those of you who are using Iceberg, and if you are not using Iceberg as well, I'd love to hear sort of, what your concern would probably be if you're working with this. So I'm going to launch another poll where you can kind of let me know, which of these you feel is probably going to be the hardest for you to implement, or something that might be really challenging for you in general, or that might be something hard for your team to work on. So I'm going to give a few more seconds here, probably going to give it like a full minute for you guys to participate, and then I will share the results as well. I'm just going to give it a little bit more time. I think that almost everybody has answered. Thank you for engaging with the poll, by the way. I know that it's tempting to have a webinar playing in the background and then going to go do your own thing if you need to. So I'm now going to end this poll, and I'm going to share some of these results with you and show you what the results actually are. So it seems like it's kind of split, but two people did state that they were working, that one of their concerns would be working with too many small files or having slower queries. And so it seems like maybe there's a headache there if you're dealing with like very high touch data, or if you're dealing with maybe some streaming use cases of constantly generating that data as well and not necessarily knowing how to manage that. And then the second I would also say is metadata bloat or performance issues. I would say that also kind of couples hand in hand with too many small files as well, because the more small files you're generating, the more metadata you're also probably generating as well. And then somebody also voted for monitoring and the observability gaps. So maybe not necessarily knowing how to leverage everything out of the Iceberg logs, or even just knowing which metrics to log and to aggregate from. So I think that's all very fair. Thank you all for voting. There will be more polls, so hopefully you don't get too like poll fatigued, but I do appreciate you being part of this. So next, we're going to talk about the catalog central role and why the IRC is so central to so much of this as well. And so if you haven't really caught up to everything that's been happening, there's been a lot of Iceberg catalog implementations that have come to surface in like the last year and a half, I would say even the last 2 years. And so generally speaking, we kind of mentioned this or touched on this before. The actual Iceberg catalog is not really anything super crazy. It's kind of just more of a pointer than anything. But with it, you can create an interface that comes with it, right? And that allows you to manipulate or work with certain tables. And that can be really useful. Some examples that you might have seen in like the previous generation include Hive Metastore, Glue, or maybe even a file system catalog as well. But we've kind of evolved from then with our governance needs, and we're going to be going over that in a little bit. So generally speaking, the catalog has to be pretty accurate when it comes to just mapping that path. Nothing super crazy there, but it is pretty much like the catalog's basic, very like bare bones functionality that it needs to do this one thing right. Everything else is kind of just like the sweetener on top. And so generally speaking, if you're working with many concurrent jobs at once, you can create a performance bottleneck here if you're working at like this really large scale production level system. And so that's why I think Rust has become so trendy, just because it works with a lot of these like concurrent systems really well. So why is maybe a catalog useful? It can tell us some really great information, kind of as you saw there, including, what are your tables or where are you like storing them and how do you access them, right? This is something that we need to be able to tell the query engine so that the query engine can perform its planning efficiently. And so if we're tracking the Iceberg tables, we can also allow external tools to interface with this metadata. So this really goes back into, the monitoring and the observability piece of kind of really figuring out where do we optimize and where do we put our efforts into. And it also allows us to better control maybe some conflicting queries and stuff like that. So Iceberg does something that's called like uh, I guess it's like optimistic planning. So generally speaking, it's kind of meant for quickness versus like locking certain tables instead. So generally speaking, if you have more control over that server side, that can be really nice if you're working with a really large system. And as these different data architectures evolve, the catalog can kind of help provide an interface between these different tools that you're using. And as your architecture evolves, you can at least have something that's quite flexible that can be your source of truth and that can move with it, right? So it's not necessarily coupled to any specific architecture requirement or need. So REST is pretty common. I would say that REST is probably one of the most popular ways to implement some sort of API. And so generally speaking, I think one of the reasons why it's caught on is because it's so simple and because it's so easy to understand. And so this way you can pull different requests and then you can have your backend handle it the way that you've defined it. And then generally speaking, REST is also pretty universally supported by all of the major engines that you'll probably use with Iceberg as well. This includes like Spark, Trino, Flink, PyIceberg, etc. And generally speaking, you'll have more support for multi-table transactions versus previous catalog implementations, like maybe say Hive Metastore, for instance. The issue with kind of running a REST server, though, is that you also need to do the work to actually store the state of the table somewhere, and you actually need to handle the calls somehow, right? And this is why we've created many different services, such as Apache Gravitino or even Polaris or other catalogs that help you kind of stand this infrastructure up. And so when you're choosing a catalog, you might be interested in some very specific questions, including, how production ready is the catalog? Has it, are there people using it in production currently? What are the dependencies of the catalog you're using? Are they dependencies that you can live with? As well, does this catalog support, the different engines and tools that you're already using? So there's a really big trend right now of making, catalogs with a lot of interoperability support within the open ecosystem. And then, can the catalog support the type of queries and transactions that you want it to? And is it vendor neutral? I think it's quite important these days to choose a catalog that actually supports, different cloud providers, that is relatively vendor neutral, generally speaking, because your catalog is going to be your gateway to your metadata, and your metadata you don't necessarily want to be locked behind a paywall, right? So I'm going to throw out another poll because I said that I would throw out a lot of polls, and so I'm really curious to see if anybody's currently using a Iceberg catalog and what are they using as their catalog. So we're going to launch this poll here and feel free to answer. I'll probably leave it up for about a minute or so. Welcome to all of the new folks that we've got in. I'm very excited to see you here and just to understand, where your journey is at. And so we're going to be getting into Jerry's part pretty soon, but I will leave this up here. So it seems like we've got a lot of Hive Metastore users actually and one Glue user, which is pretty cool. And then if you're using something that's not listed here, but you are using something, please feel free to put it in the chat. And then we'll give it a little bit more time before we show the results. I'm going to be closing this poll soon, so if you haven't voted, please do get your vote in. But I'm going to end it in 5, 4, 3, 2, 1. And thank you to everyone who voted. And I'm sharing the results now, so we can see here that 4 people are using Hive Metastore, which is actually pretty cool. And then there's also AWS Glue, and some folks who have not either implemented a catalog or are not sure, or are using something that's not listed there. So hopefully one day we can see more users on Apache Gravitino, but that's probably why you're here, is to assess whether or not it would be good for your use case. So thank you all for voting. Okay. And so the next slide that I have is going to be another poll, but we're going to save this to the end. So these are some examples of different open source REST catalogs that you might see, including Apache Gravitino. There's Polaris. There's also Lakekeeper, which is a REST native implementation, as well as Unity catalog is kind of like the iffy one here. It's not necessarily exactly what we would consider it, but because a lot of people are using it, it is out there. And we're going to also talk a little bit now and introduce Apache Gravitino. So for those of you who came, you're coming directly at the right time. So Apache Gravitino, again, created by Jerry here, was donated to the Apache Software Foundation. And it's really meant to be this unified, universal governance framework where you can really connect all of your different query engines, different catalogs, and different open table formats together to create sort of like this streamlined management system. And so if you hit that QR code or if you scan it, it's going to take you to our GitHub repo where you can check it out. But generally speaking, it's going to enable you to be able to query all of your data, whether or not it's in like a geo-distributed system or whether or not it's stored in different formats or across different catalogs or different database implementations. And you can also use its REST interface, or you can use its Java or Python API, and the CLI is actually fully implemented now. And so generally speaking, it is also released under a Apache 2.0 license, which means that it's incredibly permissive if you are interested in using it. And the way that Gravitino is implemented is using a catalog of catalogs model. So Jerry will be going over this a little bit more detail pretty much soon. But generally speaking, let's say that you have many different catalogs, so a JDBC catalog, Hive Metastore, your Iceberg catalog, or maybe some sort of like schema registry or like a model registry as well. You'll be able to create all of those and register them into our Meta Lake or our Meta Store. And then you'll be able to enact all of your governance on top of that as well, including your access control, etc. So it's a really cool framework. If you want to compare it, some of this might be a little bit out of date, but generally speaking, we do have wider support, generally speaking, than many other catalogs that are currently on the market. But we are, of course, Apache 2.0, and we do have Kafka support as well. And we have many other different security controls that have been recently added and many different engine supports that you'll see. And so we also do file set management as well. So if you have any questions around that, please let us know. And we're going to continue on here to Jerry, if you want to take over. Jerry, are you able to control? Oh, you can't unmute. Okay, I'm going to unmute you. There you
Okay, yeah.
go. We can hear you.
Yeah, thank you, Lisa. Okay, so yeah, thanks Lisa for the introduction about the iceberg table maintenance and other things like Gravitino and other catalog things. So it seems like there are multiple choice of the catalog or catalog of catalogs. So also about the brief introduction about Gravitino. So now let me walk you through the details of the how or what is the Apache Gravitino Iceberg race catalog and how we achieve these things and what kind of features do we have for the production ready deployment. So the first thing is that I want to mention is that how we build an Gravitino Iceberg race catalog. The key word is a federated Iceberg race catalog. So as Lisa already mentioned that our Gravitino is a federated catalog or unified catalog, which means we are a catalog of bunch of catalogs. So bring by the concept for the concept from the Gravitino to the Iceberg. We also build a federate layer on top of the current existing Iceberg catalogs to build our federated Iceberg unit Iceberg race catalog. So we are moving from the pluggable catalogs to the race catalog. As you can see here are two charts. One is the current existing Iceberg catalogs because Iceberg community built a pluggable catalog interface. So there are multiple implementations, and you can use the Hive implementations, which is backed by the Hive Metastore, or you can use the JDBC catalog, which is backed by the JDBC database, and also like Guru catalog and Dynamo catalog, Hadoop catalog, something like this. So the key thing is that Iceberg itself you can use the different catalogs to manage the tables. What we do is that we build a wrap layer or rest layer on the top of existing catalogs and to try to unify all of them so that we deliver a rest interface. So for the users, you already use the Iceberg with the existing catalog, for example, like Hive Metastore. So we can launch a Gravitino Iceberg REST catalog on top of the existing catalog and to give user a REST interface to talk with the Iceberg tables. And what user need to do is just simply launch a Gravitino Iceberg REST catalog and then change the Iceberg client from the Hive client to the REST client, then everything goes fine. So that's the key thing of our Gravitino Iceberg REST catalog. And also, if you have the multiple Iceberg catalogs existing, for example, you have multiple Hive Metastore or you have multiple JDBC catalog, then we provide a federated way. So you can use the one Iceberg REST catalog to talk to the different backends and process it in a unified way. So how do we achieve these things? Let me walk you through the details. And you can see in the left side is our engine. So you can use the different open source engine which support Iceberg, for example, like Trino, Spark, Flink, or others. And then the engines inside each core engines, there is a Iceberg REST client which talks to the Iceberg REST catalog service, and it is our Gravitino Iceberg REST catalog service. So our Gravitino Iceberg REST catalog service is kind of a catalog implementation which supports different catalog backends. For example, we can support like Hive Metastore backends, and we can support JDBC backends. We can even build our own backends to support. And on top of this, we provide several production-ready features like matrix systems, like authentic tools, like matrix storage and authorizations and others. So with this, the Iceberg client inside the query engine can talk to the Iceberg REST catalog service to load the table and to commit the table and to do whatever they want for the metadata operations. And they don't need to care about the details about the consistency, transaction. All this will be handled in the Iceberg REST catalog server. So the client is very simple. It's just a wrapper of the REST APIs. And after that, commit the metadata, then we will talk to the query engine will talk to the storage to actually commit the files. So that is the same way as previously catalog. There's no difference. So as you can see that with our Iceberg Gravitino Iceberg race catalog bringing, there is no much difference compared to the existing ways, and it is very easy to use and to land to your existing stack. And but with this we bring a lot of different features and functionalities based on the server side raised things. So then I will walk you through the details about our features. And another thing is that as Lisa already mentioned, that Gravitino is a unified catalog. So it provides a unified APIs for user to manipulate different tables. But we also have a Iceberg REST API support, so user can use the Iceberg REST APIs to manipulate Iceberg tables. So there are two different ways user can use our unified REST APIs and also can use Iceberg REST APIs. But these two APIs, the functionality is similar and they can manipulate on the same table. So if you do the table alteration from the one using one API, and then it can be read from another API, and but why do we have two different APIs or two layers of APIs? And one thing is that for the Iceberg REST APIs, if you have Iceberg space features or specific functionalities like time travel things, Iceberg table API will support better. But if you want more additional features and production-related features like authorization, authentication, and governance audit, then the Gravitino API will provide more functionalities on top of Iceberg REST spec. So we provide two APIs for you to choose. You can choose either API to do the query, to do the table processing, or do the additional things. And also we add a lot of features to enhance the serviceability and expansibility for users to land Iceberg risk catalog on the production environment. First thing is that we add a matrix system, also the centralized auditing system in the Gravitino IRC. And this matrix system can be talked to the connect to the Prometheus uh, using to scribe some metrics and to build a monitoring tool. And also our audit log can be scribed that by the Grafana log, and then you can collect the audit log and to better understanding who do the table operations. So that's the one features we added to enhance the production ready. And another thing that I mentioned already is that our Gravitino Iceberg Risk IRC is a pluggable. We support pluggable catalog backends. Currently, we already support like Hive, JDBC, and others. And in the future, we can support like S3 catalog so that you have some S3 tables existing on the S3 on AWS S3. Then we can manage it with Gravitino IRC in a unified way. And we can also support Polaris and others as a catalog backend. Then Gravitino IRC will be the unified ultimate endpoint to talk to the different backends. And besides, we also support lots of events for the pluggable listeners. So you can implement different event to inject your code and do the customize, and then you can satisfy your needs or your requirements. And also, last but not least, and we also support flexible deploying. So as we mentioned that Gravitino is a unified catalog, and Iceberg Risk Catalog is one part of functionalities in Gravitino. So if you want to use all, not just Iceberg Risk Catalog, but also the Gravitino unified REST catalog abilities, then you can deploy them in a single process. But if you want to split them differently, or you want to only use the Gravitino's feature, or you only want to use the Gravitino Iceberg race kind of learn, then you can deploy them in two different separate processes, and they can flexibly deployed and without needing to binding one to another. So that's the sum of the features for serviceability and extensibility. We're still adding more, and if you have more requirements and more features, you can let us know in the issue and in the GitHub issue and other places. And also, it is very important for production-ready use is that security and access control. So for the Gravitino IRC, we also add a lot of security and access control features. The first thing is the end-to-end authentication support, because it is quite important to know who is who. So we provide end-to-end authentications. The first thing is that we provide a pluggable authentication layer on the existing IRC. And this pluggable authentication layer can support different authentication methods like OAuth2, Kerberos, and others. And the user can implement their own to achieve their own authentication method. And also when the Gravitino IRC talk to the backend catalog backend, we also implemented the authentication for different catalog backend. For example, like for Hive, we can support Kerberos and delegation token with user impersonation. And for JDBC catalog, we support the user and password. And for different catalogs, we can support different authentication tools and methods. And also when we access the actual data, we also support authentication to the file systems or storage. For example, if your table is on the HDFS, we support the Kerberos and delegation tokens. And on the cloud storage, and we provide a more convenient ways, which is called credential vending. This is a mechanism which let Gravitino IRC to get tokens for you, and it will get tokens for you to access the table. And for example, if you want to access the Iceberg table on the S3, and then when the credential vending enabled, then the Gravitino server will get a temporary token and pass the token to the client, and the client will use this token to talk to the S3 and then get authenticated. So this is end-to-end authentication, and this is very important, and which will let user know who can access and who is who. And then we also build an access control layer using our role-based access control model. And this is not the Iceberg race spec. This is our Gravitino's own features, but we can use our Gravitino's unified ABAC model to authorize the table. Then this table can be controlled by our system, and when user fetch the table or when user do the access. For example, we provide a unified authorization APIs for users. User can use our unified authorization APIs to create users, groups, and also create roles with privileges and secure objects. And with these roles, roles can be bound to the users and the groups. And then when user access the table with Iceberg client, and then these roles will be enforced in Gravitino, and to check whether the table is whether the user has a permission to access the table or modify the table. And this is the enhancement to the Iceberg REST spec, and which is also important for the production-ready use. And also, we provide a lot of governance abilities on top of Iceberg race catalog. So here I just list three main features we provided. We will we're also having more. Please check out our Gravitino repo. And the first thing is about our tag support. Tag is used to do the data classifications. So with our Gravitino provided unified REST APIs, you can tag the label on the different metadata or different entities. For example, like on the catalog, schema, and table, and then you can know you can do the data classifications based on the tags, and it can let you to better classify the sensitive data, something like this, and do the data regulation things. And also we provide a search API. And Gravitino provide a search mechanism for data discovery. So your Iceberg table will also be the metadata will be also be loaded into a search database, and then we provide in the API so you can do the random search and to get the actual to get the table metadata. And we also provide a lineage API. So when you process the Iceberg table, the lineage information will be pushed to the Gravitino using the lineage API. Then the lineage information will be recorded in our database, and it will be showed using the API or using the front end. So we are continue adding more features for the governance. So this is the three main things currently we already supported. And also for the future things for the IRC, I think we still have many things need to do. I think the most important things, as Lisa already mentioned about, is table maintenance. Because Iceberg table is unlike the Hive table. It has a more complicated data structure. And also with the support of the new real-time data ingestion, we will suffer from the problems of the lot of small files or deleted files. So how to balance the read and write performance is very important. So we will provide a series of the table maintenance tools and implementations like file compaction, open file removing, snapshot expiration, something like this to let user to better use the Iceberg table without needing to know the details. And also we will adding more performance level features like fast partition listening and metadata caching things, because now we are moving the metadata operation from the client side to the server side, and the REST server IRC is a centralized place to manage the metadata. So it has the ability to do more optimization ways to improve the performance compared to the previously client-side improvements. So we will continue working on this thing. Another thing is that we will continue to federate more different catalogs like S3, Polaris, the Keeper, and others to make sure that Iceberg is the Gravitino Iceberg REST catalog is the centralized place for users to access. And for other security authorization, access control, authentication, and we will continue adding more customer-related features and for user to easily to adopt their own methods and solutions. Yeah, I think that's from my side, Lisa.
Awesome. Thank you, Jerry. That was a really great in-depth. So Jerry is going to be hanging around to answer any questions that you might have as well. Feel free to also put them in the chat, and then he will be able to get to them either as you're typing it out, or at the end we'll be able to read them out for you. Perfect. So next, I also want to have one last poll. So this is going to be our last poll of the day, which I'm sure everybody's very sad about because they love polls so much. But if not, then that's okay. This is not the poll I was hoping for. Let me get this one. So it's only one question, but generally speaking, in your opinion, or as you're looking at different catalogs, I'm really interested to see from other folks, how important is the multi-catalog or the cross-engine component of either Gravitino or in a catalog in general to you. So feel free to vote. If it is something that you are, really interested in, or if it's something that you're not interested in at all, it would be really great to know. I'll leave it open for about a minute, and then we're going to get into some demo stuff. We'll probably run a little bit over the 7:30 time, but we'll be hanging around, and we really want to make sure that everybody gets any questions answered as well. And I'll leave it up for just a little bit more, probably for about 5 more seconds. So 5, 4, 3, 2, 1. And I'm going to now end this poll. So thank you for everybody who voted. So generally speaking, it seems like people think that it is important, but they don't necessarily know, maybe the specifics of what they need or what specifically they're looking for in sort of a catalog, as well as something that's either critical or not relevant as well. So I see in the chat, Krishnaya has a question, which is going to be great. We're going to hit this at the end. So if you want to throw all of your questions in the chat, we'll answer them all at once. But thank you for answering them. And so I'm going to share these poll results really quickly for folks so that they can see. And then we're going to get into a quick demo video that we have that Justin has lovingly prepared for us.
Hi, my name is Justin McLean, and I'm involved with the ASF in a number of ways. I'm currently a director of the ASF, and I'm also the VP of the Apache Incubator. And I'm involved with a project called Apache Gravitino, which is obviously what we've been talking about for the last 10 minutes or so. So I'm just going to give you a quick overview of how to get started with Apache Gravitino and show you some of its features. So one of the easiest ways to get started with Apache Gravitino is to use the Gravitino Playground. So this playground is a group of Docker containers that gives you enough an environment to set up and run and start playing with Apache Gravitino. So all you need to do is clone the playground, and I have already done this. And so I'll just show you all the files there. And there's a playground.script, and you can just go playground start, and that'll go off and, if need be, download all the Docker containers and then start them up. The first time you run this, it's going to take some time. It'll probably take 10 or 20 minutes depending on your internet connection speed. But once it has downloaded those containers and you start it up again, then it's only going to take about half a minute. So we'll just wait while that gets started. So you can see there that it's starting up a whole lot of different containers. So we've got Postgres and Hive, MySQL, Arranger, Prometheus, Graphene, Spark, Gravitino, Trino, and Jupyter. We can go to our Docker desktop, and we can see all those are running in there. It will also start up Apache Gravitino, and you can see that it started up and it already has a metal lake there. And inside that metal lake are several catalogs that have already been created for you. So, that is a simple way to get started with Gravitino. There are some other ways that you can also get started if you want, and we have documentation about this on our website. If you go to the Apache Gravitino website and click on the download area, you can see the latest release. We're currently working on a 0.8.1 release and also a 0.9 release, and they will be out in the next month. So you can either download the source and compile it from scratch and start it up yourself that way. It won't have all the other services that the Playground gives you, so you'd have to integrate those yourself. So that's going to be a bit more work. And there's also a convenience binary there that you can download, and you can run it straight away without having to compile it. So enough of that. Let's actually have a look at Apache Gravitino. So if we go back to the UI, the UI, by the way, is not the only way of interfacing with Apache Gravitino. As well as the UI, it has a REST catalog, and it also has a Java API, also has a Python API, and also has a command line interface. So you can interact with Apache Gravitino in all those different ways, and just depending on what you're trying to do, you'll pick one over the other. So if we have a look at our Iceberg catalog here, we can see that it doesn't actually have anything in it. But that's okay. So we can create a schema in that. There's a number of different ways you can integrate with Iceberg. Let's take a look at those first. So if we have a look at the documentation here, and you can see that with an Iceberg catalog, that it supports Hive, JDBC, or REST as the catalog backend. We're going to use Hive, and that's just because we've got everything running locally in Docker, and that makes it easier. But you don't have to have things running locally. You can have the storage being in the cloud, such as S3 or Google Cloud Services, and a few others that we support as well. You can see all the documentations here, and they explain in detail what properties you need to set up each one of these catalogs. If we go back to our Gravitino server, so let's create a schema. And inside that schema, let's create a table. We're going to call it employees. And we're going to give it some names. So I'm going to start with a full name, which is of type string. We're going to have position, also a string. And then we're going to have date of birth, which is obviously a date. And we'll have date joined, which is also a date, and date left. It's also a date. So we've got a very simple table there, but we'll just create that. And this will actually go off and create the table in Iceberg. What we're looking at in the interface here is the metadata, but we can see that. Now, obviously, this table doesn't have any data in it yet, and we'll get to that in a minute. But you can see the column names there that have been created. And this is a representation of what is actually in the Iceberg. And if the changes were made to the Iceberg tables, that would propagate through to the interface, and you'd see those changes without having to do anything. So let's insert some data into that database. I'm just going to use one of my favorite tools, which is dbeaver. I'm just going to refresh this. Right, so we have an Iceberg schema here, and if we have a look at the tables, we see we have an employees table. So let's import some data into that. And I'm just going to pick this file here. Let's go next. We'll probably have to do some mapping on the fields. So let's have a look at what's the field here? Date joined. Date left. So just some of the columns are named slightly differently, but they've got the same sort of data in them. So let's proceed with importing that data there. That'll take half a minute or so. Typically, your Iceberg tables are going to have more data than this in this, but this is just a quick example to show you what it's capable of. Right, and there we go. And so we have now got that data imported into an Iceberg table. And we can, using Gravitino again, so if we create a SQL script there, create a new one, and if I just say select star from catalog iceberg.employees, and just run that, you can see that it goes off and gets all the data that's inside that Iceberg catalog. So there we go. There's a very quick introduction to what you can do with Gravitino and Iceberg. We have other Icebergs features as well. We also have a standalone Iceberg REST services, which may be of interest to some people. And we can also, this is, just starting to look at what we can do with this. We can also, for example, do cross joins between Iceberg and other catalogs such as MySQL or Postgres or Hive. You can see we've got those set up in the playground as well.
So big thank you to Justin, who is somewhere that is not here right now, but he is with us in spirit. So I think that was a very, low level or quick introduction into how to get started with Iceberg. Of course, there's a lot more that you can do with it as well. And we're hoping to get some more
Hi, my
materials
name
as
is
well for
Justin
folks. Oh
McLean,
my gosh.
and I'm in.
Justin, that is okay. We don't need more. And so if anybody is interested to learn about the Gravitino community, so we are one of the fastest growing communities. And if you even want to compare it with the Iceberg project as well, we have reached quite a few number of stars in terms of trajectory. And we've also hit 1 million downloads in the first 9 months. And so that's obviously been picking up quite a bit as well. And if you want to compare it with some other repositories, it's quite active. And we also have a really amazing community that is contributing and helping us test some of these things, both in production and at POC levels. Of course, if you were at the Iceberg Summit, then you would have seen that Pinterest is currently using us as well, and Jerry presented there. And so you can probably find that video on demand in terms of that presentation. And we're excited to kind of showcase some of the more use cases that we'll see from these different organizations and partners as we continue onwards. And so now comes the Q&A that I'm sure you've all been waiting for. Thank you to everybody who stuck around. Jerry, I'm going to ask you to unmute again because I'm going to get you to answer most of these questions. And let me see. All right, so the first question is from Raghav, which is, what is the performance impact of adding the Gravitino Iceberg catalog?
I think the performance impact is quite low. Mostly because we are a race layer on top of the existing catalog, so we are not the performance bottleneck or the performance penalty things. So and as we had a presentation in the Iceberg Summit with Pinterest. They have some like performance statistic metrics or numbers to show the performance, right? And if you can check that presentation to know more about the performance things. But as I said, it is a race layer, so the performance should not be the major issue here.
Awesome. Thank you, Raghav, for your question. If you have any follow-up ones, please feel free to let us know. So second question here from Krishnaya, and hopefully I'm saying that correctly. Is the Gravitino service, does it have super admin credentials?
Okay, so seems like the question is that how credential vending works and is Gravitino service has a super admin credentials, right?
Yeah,
Okay,
I believe
so
so.
yeah. Let me quickly introduce how the credential vending works. So credential vending is a mechanism provided by the cloud storage providers like S3, like GCS and others. They all provide such mechanisms. So it's unlike the IAM, and it will grant you so they are the super admin. They grant you a temporary token for you to access the object or the bucket. And that's why this credential vending tool is much more better than the IAM way is that and the first thing is that for the service can help the client to get the token and pass the token to the client, and then client can talk to the storage directly using this token. So no need for the client, each client to get a token. So for the client, it is transparent and very easy to use. And the second thing is that the token is a temporary token. So it will be time out like 1 hour or 2 hour. So this it will be much more secure than the IM way. And I think the most important thing is that it is much more convenient compared to configure IM one by one for each client. Instead, the server can represent the client to get the token and pass token to the client, and the client can directly talk to the storage with this token. This is more convenient way and a more robust and secure way. So I think this is the how credential vending works. And I think the cloud storage, they are the main of the vended tokens, and Gravitino only helps the users or helps the clients to get the token and then pass the token to the clients. And we will not manage the tokens. We only manage the like life cycle of the token. If token is expired, and we will help users to get a new token, but we are not the ground choose place of the token. The token is always issued by the cloud storage. Yeah.
Awesome. Thank you for that amazing answer. So that was that sounds like a second webinar that we can do as a follow-up, which is how the credential vending works in Gravitino. So we have another question. So this is a little bit longer from Bharath Krishna. So again, hopefully I said your name correctly. So thanks for the presentation. I see that there are two sets of REST APIs. Do we need to pick and choose which one to use? I'm wondering, otherwise it can cause some race conditions, etc. If both are being used or both set of APIs are mutually compatible.
Mhm. So yeah, we provide two sets of REST APIs. One is our Gravitino REST unified REST API. Another is Iceberg REST Spec API. So uh, our Gravitino REST API is defined by Gravitino community. So if you want to use it with a query engine, then you need a connector or for these query engines. For example, we provide Spark connectors. So without this, it cannot talk to Gravitino. So this is one additional things need when you use this set of API. But for the Iceberg REST APIs, the Iceberg community already provided connectors for the different engines like Spark, and so if you already use the Iceberg client, then it is very easy to use the Iceberg REST API, then the Gravitino API. So if you already use the Iceberg, then it will, if you want to keep the compatibility and do not want to migrate a lot, then you can use Iceberg REST spec, Iceberg REST APIs. But the difference that Gravitino REST API, we provide a unified way to manipulate different tables, and we also provide a security and governance and different functionalities on top, other than the Iceberg REST API. So if you want to leverage more features of the Gravitino, like you want to do the access control things and you want to do the governance things, you can use our Gravitino API. And these two API, they have the same destination. For example, if you want to manipulate on the same table, and then they will be controlled by by the by the internal mechanism to make sure that these two APIs will not be conflicted. So we have the such kind of consistency or transaction mechanism to guarantee these things. So if you can choose either API, but there's no problem. They have the race condition issues. And also these two APIs is mutually compatible. If you operate table with one API, then it will be affected by the other API. So yeah, I think these are okay. Yeah. Yeah, that's it.
Thank you so much, everybody. We're going to, wrap up this webinar here. I know that some folks have dropped off, but for everybody who has stayed, thank you. And of course, thank you, Jerry, for taking the time to join us today. I think that today was pretty successful. And if you have any more questions, feel free to reach out to us directly. For me, my email is lisa@datastrato.com. You're also welcome to raise issues on the repo. We're very active and we keep really close eyes on it as well. And so thank you again for joining.
Thank you.
Great. I'm going to